Hi students, good morning. Today I am continuing the lesson force and pressure, and in my today's class I am explaining the concept pressure. Pressure is a physical quantity and it is a vector quantity. The physical quantity pressure is defined in such a way that the force acting on unit area of a surface. Here the definition is like this. The force acting on an unit area of a surface is called as pressure. And according to the definition of the pressure, pressure is equal to force by area. In the numerator side, the physical quantity force it will come, and in the denominator side, the physical quantity area it will come. And according to the definition, force acting on a unit area is called as pressure. And this can be written as P is equal to F by A. And according to this equation, P is equal to F by A, the two derivations will come, and from this it is concluded that pressure is directly proportional to force. As the force increases, pressure on an object also increases. And next, pressure is inversely proportional to area of the surface. As the surface area increases, pressure decreases. As the surface area decreases, pressure increases. So this is how the two derivations we will come to now from the equation of the pressure. P is equal to F by A. And according to this equation, P is equal to F by A, pressure is equal to force by area. The SI unit of pressure is to be taken as Newton per meter square, just because the SI unit of force is Newton and SI unit of area is meter square. When this area is taken to the or brought to the numerator side, meter square, it becomes meter raised to minus 2. So that's because it is to be written as Newton meter raised to minus 2 or Newton per meter square. Both are correct. This is how the explanation of the pressure it will be given. And next it is said that not only the solids exerts the pressure, and liquids and gases also exerts the pressure onto the surface area in contact with them. And it is said that liquids and gases, together called as fluids with a common name, exerts pressure onto the walls of the container in which they are filled, onto the walls of the container, and also in the downward direction, just because of the gravitational force of the earth. So this is how liquids and gas also exert the pressure onto the walls of the containers. And this can be proved with several illustrations. Let us take a beaker, and in the beaker, the 3/4 portion of the beaker is filled with water, and at the bottom, let us make a hole. And now, when the hole of the beaker, which is made at the bottom, it is opened. So then, what happens is, whatever the liquid filled in the beaker up to the 3/4 portion, so that starts to flow with a high amount of force, just because even though no external force is applied on it. So whatever the explanation is like this: the beaker, 3/4 portion of the beaker is filled with the water, and when the hole is made at the bottom, so what happens is, whatever this water, it starts to flow down with lot of pressure, even though no force is applied externally. No external force is applied on the water, just because of the reason is what, that is the pressure. So here, water, so called as a liquid, so starts to flow. So just because it is exerting the pressure, in the downward direction. Okay, and same cases of the gases also. When we start to fill the air inside the balloon, and what happens is balloon shows bigger balloon starts to expand, it shows the increase in the size just because whatever the air we are filling in a balloon, so it exerts a pressure onto the inside walls of the balloon and balloon starts to expand. And if we want to, if we continue to fill the air inside the balloon continuously, then what happens is the balloon starts to expand and at last, in the last stage, what happens is balloon bursts and it blasts with a sound just because of the pressure inside the walls of it. So with this experiment, it is proved that whatever the liquids and gases exerts the pressure on the inner walls of the container. Thank you.